All right, hey everybody. Thanks for coming to my session today. So my name's Kelly Bryant. I'm in the product planning and marketing team here at AMI. And I want to talk about your platform firmware. As most people know, your platform firmware is one of the most powerful things that runs on your platform. It's the first code that runs. It can also read and write without restriction. Now the problem is that because your firmware is proprietary, you can't control it. There's nothing you can do about it, okay? So that's where open source firmware comes into play. Open source firmware is going to completely change that paradigm by not only giving you, the system owner, the ability to own that firmware, but also to innovate on that platform and also make sure it runs more secure, okay? So the goal of my presentation today is to review with you how using open source firmware, you can not only power up your system, but you can also ensure that it stays on, and you also can make sure that it runs secure. All right, so just very briefly, a little bit about who AMI is. AMI is a foundational technology company. We've been providing firmware to the industry for years. So this includes your supply chain ODMs, your system manufacturer OEMs, end users, right? We call them point of use. So data center, enterprises, CSP, hyperscalers, all have been using our firmware for years. Now we are a very proud contributor and partner with the Open Compute ecosystem. We're very active in the open source firmware, in addition to the hardware project management groups as well. Security of our firmware is something that we're keenly focused on. We have founded a cybersecurity research center at Colorado State University, where we focus on obviously security research. We also support ethical hacking to make sure that we find gaps in our code as well. We're also active members of NIST and the NCCOE, so the National Cybersecurity Center of Excellence, with many ongoing engagements. So confidential computing being one, secure 5G telco being another, in addition to supply chain security. All right, so the question I get all the time is, so why is AMI interested in open source, okay? Well, quite frankly, it's a requirement. It's what customers are demanding today. And if you look around, some of the most innovative companies in the world today are using or have plans to use open source firmware to power their platforms. So this year, when OCP mandated that all their hardware platforms, their future hardware platforms, use open source, AMI decided to go all in, okay? So we're completely embracing open source. So in May, we introduced a completely new product portfolio that includes all of our open source products, and I'll go through those here in a little bit. Now, one of the key points I want to make is that AMI's goal here with open source is we want to be a good open source corporate or citizen for the open source community. We want to actively engage with the community. We want to make sure that we are engaged in dialogue, collaboration, feedback. We ultimately want to partner with the community to come up with a common platform, if you will, for the industry to further accelerate the innovation curve, if you will, okay? All right. So your platform, okay? So your platform is a combination of hardware and firmware components needed to boot your system, to power it up, to operate it, and to make it run secure. All right, the problem, as I alluded to before, is today this is a black box to you. You can't do anything. You can't do anything with it, okay? So that's where open source is going to give you a unique opportunity to now own your firmware, okay? You're going to own the foundational firmware of your platform, all right? The other thing, it's going to shift the plane of control, if you will, in terms of you now being the owner, which is where it belongs. So what does ownership mean? Well, ownership means you own it all the way down to the source code. You can now peer in your machine to understand exactly how it operates. You now can change your firmware, modify it, add capabilities to it. You can share it. You can do whatever you think is necessary for your platform, okay? Now, what are the other reasons to go all in on open source besides ownership? Well, there's three. One is quality and differentiation. Quite frankly, open source is going to let you build better products because now you control all the core capabilities that go in your platform. Speed, okay? Your open source is going to be optimized and streamlined for your platform. It's only going to contain the code that you want on that platform. Nothing more, nothing less, okay? And as a result, it's going to run faster, it's going to be able to execute faster, it's going to have much better behavior. The last is security and transparency, okay? And you know, security is top of everyone's mind today, okay? Now, by the very nature of open source itself, the fact that it's accessible by everyone, auditable by anyone, it's going to greatly reduce your attack surface area. So the ability for someone to put in a back door is greatly diminished. Now, in the event that there is a security issue, okay, you're going to be much quicker to be able to resolve that issue in terms of any specific firmware vulnerabilities or any sort of security threats. Okay. All right, so now you own the platform. Just because you own it doesn't mean you should go it alone. Okay. If you're going to support and develop a commercial platform with a 10-year life cycle, for example, you're going to need the support of a strong community ecosystem. You're also going to need the support of a strong partner for multiple reasons. Okay, so the first is you need fast-paced source code development with the ability to sync up to the upstream projects every 2 to 3 weeks to make sure you're adopting the latest and greatest changes. You need a strong community ecosystem to do that. Okay. Now, as part of your fast-paced development, you're going to need automated firmware testing. Why? Because you need to do extensive validation on your platform. Okay, and the only way to do that efficiently is you need to have an automated firmware test scheme that does that. Okay, you need to have a streamlined CI/CD process because you want the ability to build multiple silicon generations across multiple compute platforms with a single project, a single push of the button. You're going to want a partner that has relationships with all the key silicon vendors, that supports multiple reference platforms. And then probably most importantly, you need to have a partner that has a strong working relationship with your supply chain that can address any sort of issues that comes up and also to ensure supply chain integrity. Okay? Now, without that, it's likely that some of your platforms may not be updated. They may not have the security that you need on that platform. It's possible that you could have a malfunctioning system that's discarded despite having an easily firmware fix that you can apply to it. Okay, so let's talk about the source trees. So as I mentioned before, in May of this year, OCP mandated that all new hardware platforms must have open source firmware for transparency, reliability, and security. Okay, so AMI contributed its open source firmware for standard boot firmware, so EDK2, in addition to Linux boot. We also supplied an OpenBMC solution as well. Now, those are completely accepted by OCP. They've gone through the peer reviews. Today, the platforms that we support are Tioga Pass and the Mountain Jade. Our plan is to completely expand that hardware footprint. Every quarter, we'll be adding additional hardware. Next year, or next quarter, we're going to be adding Awanda in addition to Junction City. Okay. Now, the way this works is that our open source trees are based on the mothership. Okay, so we pull from the Linux Foundation, OpenBMC, the Tiana Core EDK2. Okay, now the first thing we do is we create what we call a live tree. This is where we do all our development. The first thing that we do is we want to make sure that tree's secure. So we're going to run multiple security scans. We're going to run static code analysis to make sure that we find and address sort of any vulnerabilities. Next thing we're going to do is we're going to run our extensive validation tests from all of our years of firmware testing on that, and we're going to make sure that we address sort of any bug fixes. We will also add additional capabilities that we feel is needed by the community. So for example, for OpenBMC, when we released that, we supported or we added to it additional RAS capabilities, additional IPMI commands, additional management capabilities, just to name a few. Okay. Now, I just want to make it clear, our goal is not to create a separate tree. Okay, far from it. The only reason we're doing that is because if we're going to guarantee certain service level agreements and support to our customers, we need to have an acceptance test, if you will, something that we can validate the stack with, the tree with, to make sure that AMI can stand behind. So since we know it, we know that we can stand behind that and guarantee our customers the support that they're signing up for. Okay, so then we take that and then we create a release which we push to the OCP community. That is what end customers, data centers, enterprise customers, hyperscalers can use to build on OCP hardware, okay? Now, we will then validate that on all the supported hardware on every release. We'll validate that on all the supported hardware in the repo. We'll also do integrated open BMC testing under the OCP GitHub umbrella as well. If there's any issues found, we will support it. We will commit anything back to the upstream project as well. The other thing is we want to work with the community to upstream any critical features that they feel is of value to the community. We will work in good faith for you on that, okay? So we have the trees. How do you operationalize this? So we're going to maintain two clouds, if you will. So we have an OCP cloud, and then we have a OpenEdition commercial cloud, okay? So the OCP cloud is housed in the OCP GitHub repository. So again, we pull from the mothership, right? We'll contribute back changes. This is what end customers can use to build OCP platforms. Now, you don't need to have a support contract with AMI. If you found issues, report those back to the forum, and then we'll get back to them. If you need support of services for whatever reason, you know, we have that capability as well. Now, if you need advanced capabilities or more professional services, for example, or want to work on a non-OCP platform, that is what the commercial cloud is designed for, okay? Again, if you're going to support a cloud or support a commercial platform, and let's just say for 10 years or more, you're likely going to need a platform refresh. You may need additional features to keep up with the market. Of course, you're going to want all the latest security enhancements and bug fixes. So that's what that's intended for. And the other thing that you get with this is you get access to the live tree, and then you get advanced build tools. So we have a tool, a cloud-based services tool called DevNet. It's basically for source code development and distribution. It's got full Git source control. It's a complete DevOps solution for firmware development, okay? In addition, we also have firmware-based orchestration. So if you need to generate configuration files or instructions, image generation based on various silicon models, we have that capability as well. Okay, so today, our OpenEdition product lines come with an open license. These are housed today in the OCP repository. Again, you know, these are fully accepted by OCP. Now, the way the support works is that we have a tiered model. So we have a standard offering, a essentials, and a professional offering. Each of those has various SLAs depending on what you need. They all for defect resolution, you know, how fast we respond, that kind of thing. It has a set of core services for each of those offerings. You can also add incremental services. You can bundle a la carte depending on what you need. We want to work with you to make sure that we can customize an offering that fits your need here, okay? Now, as I said earlier, okay, our intent is we are going to expand OpenEdition across the entire suite of the AMI products. So we are going to extend this to our hardware root of trust products. These are all NIST 800 193 compliant, so support detect, protect, recover. And at AMI, we take a holistic approach to security. So just like Aptio and MegaRack, we have a full offering for our security offerings for not only security of the firmware, but also the hardware itself, okay? All right, so just in conclusion, I just want to leave you with one thing. One is that technology freedom, your ability to innovate and make sure you have a secure platform, that should be the norm, okay, as you race to build your platform. Okay, and that's exactly the value proposition that you get with open source. And AMI is committed to working with the community with our foundational open source technology to enable you to do that, okay? So if you would like to learn more, to see a demo, we'd love for you to come to our booth. It's right over here, B112. We have a hardware root of trust demo running. It's based on a DC SEM module. We have an Ampere platform with our code running on it. We have the Tioga Pass running our OpenEdition products over in the Experience Center. Okay? All right, so with that, I want to thank you, and the AMI team thanks you.